Now let's take a look at how to graph exponential functions using transformations. Transformations of exponential graphs behave similarly to those of other functions. So just as with other parent functions, we can apply the 4 types of transformations, namely the shifts, reflections, stretches, and compressions, to the parent functions f of x equal to b to the x without loss of shape. For instance, just as the quadratic function maintains its parabolic shape when shifted, reflected, stretched, or compressed, the exponential function also maintains its general shape regardless of transformations applied. Now, the first transformation occurs when we add a constant d to the parent function f of x equal to b to the x, giving us a vertical shift d units in the same direction as the sign. So when adding a constant d, so when you add a constant d, that means we are shifting the function b to the x along the y-axis d units in the same direction as the sign. For instance, if we begin by graphing f of x equal to 2 to the x, this is how the graph would look like. And then we can graph the function 2 to the x plus 3 by shifting this function here 3 units along the y-axis. So we're going to shift this function upwards, 3 units upwards. So we have 1. So we do that by starting with this point, and then we move that 3 units up. So 1, 2, 3. So that point, this will be the new point. This point here will correspond to this. And then we maintain the same behavior, an increasing behavior. And then also the asymptote here, the asymptote which is y equals 0, will then be shifted 3 units up. So from y equals 0, it will now be y equals 3. That is the new horizontal asymptote of the function 2 to the x plus 3. Now, if we are to graph 2 to the x minus 3, if we begin by graphing 2 to the x as our parent function, 2 to the x minus 3 means that we are going to shift this curve here 3 units downward. So this point, the point 0, 1, when shifted 3 units down will be, so you shift it 1, 2, 3, this will be the new point here. It is equal to 0, negative 2. And then you maintain the same behavior, an increasing behavior, and also the asymptote, y equals 0, will be shifted 3 units down, and that becomes y equals negative 3. So the next transformation occurs when we add a constant c to the input of the parent function f of x equal to b to the x. This gives us a horizontal shift c units in the opposite direction of the sign. That means if I'm going to start with a function f of x equal to 2 to the x, and I'm going to graph the function g of x equal to 2 to the 3 plus x, 2 to the 3 plus x. In this case, we added a 3 to the input function. And this means that I'm going to shift this function along the x-axis. And the direction is opposite of the sign. So if this is positive, I'm going to shift this function 3 units to the left. And in here, for h of x equal to 2 to the x minus 3, if I begin by graphing 2 to the x, I will just shift the graph of 2 to the x 3 units to the right. That is in the opposite direction of the sine of c. So to illustrate that, let us consider this function here. We have the function f of x equal to 2 to the x. To graph h of x equal to 2 to the x minus 3, we just shift this function here 3 units to the right. To do that, you are going to start with this point here, and then you shift that 3 units. So 1, 2, 3. That would correspond to this point. Now the asymptote y equals 0 will remain the same. It would only change when the shift is done vertically. Here, the shift is done horizontally since you're adding or subtracting a constant to your input function. So in this example, for this curve here, this is the graph of the function 2 to the x shifted 3 units to the left. So to do that, to graph g of x equal to 2 to the x plus 3, you begin by graphing 2 to the x. So we have 2 to the x here. And then using this point here, you shift this 3 units to the left. And that would be the new point. And then you just have to make a smooth curve passing through that point. Observe that when we shift our function horizontally, the domain remains unchanged, and the asymptote y equals 0 also remains unchanged. And so therefore, for any constant c and d, the function f of x equal to b to the x plus c plus d shifts the parent function. This is the parent function, b to the x. This shifts vertically d units in the same direction as the sine of d, and horizontally by c units in the opposite direction of the sine of c. And the y-intercept becomes 0 b to the c plus d. And the horizontal asymptote becomes y equals d. And the range becomes d to the infinity. And the domain remains unchanged, which is still equal, this is still equal to negative infinity to infinity. Now to graph a exponential function of the form f of x equal to b to the x plus c plus d, first you draw the horizontal asymptote y equals d. Because of the d here, we have a shifting along the vertical line, along the y-axis, so the asymptote will also be shifted d units, either up or down, depending on the sign of d. So draw first the horizontal asymptote, and then you identify the shift as negative c or d, or in other words, start with the point 0, 1, and then shift it, either you shift it first along the x and then to the y, or y first then x. So that means you identify the point negative cd. And then shift the graph of the function b to the x, d units if upwards if d is positive, and d units downward if d is negative. Now state the domain of the function. That will remain unchanged, but the range will change if there is a vertical shift. The range will be d to positive infinity if there is a vertical shift. If this one is 0, there's only a horizontal shift, the range will then remain the same. And the horizontal asymptote is y equals d. Let's answer this conceptual question here. Which of the following is not true for any constant c and d, the function f of x equal to b to the x plus c plus d shifts the parent function f of x equals b to the x? So is this true or false? The horizontal asymptote becomes y equals c. Now, the horizontal asymptote shifts if there is a vertical shift, that is, if there is a d. So from y equals 0, it becomes y equals d. So A is false. This should be, so this one is false. Instead, you have y is equal to d. The range becomes d to positive infinity. Yes, because there is a vertical shift here. So the range would also, the range will change. The domain remains unchanged. That is true for any shifting, whether it's along the vertical or horizontal line. Now this question here. The first transformation occurs when we add a constant d to the parent function f of x equals b to the x, giving us blank units in the same direction as the sign. So what type of shifting do we have if we add a d to this parent function here? The answer is a vertical shift d. So this gives us a vertical shift d in the same direction as the sign.